2.3 equations of lines. So we're dealing with linear equation of two variables. So somewhere there in your notes, have just a section. It's just going to be create a list, and so all the equations we're going to deal with in one place. So I'm going to kind of just do that here on my whiteboard. And the first one I consider is just ax plus by equals c. So a, b, and c are arbitrary constants. X and y are the variables. And when we have a linear equation, which just means the highest power on the variables is 1, in this form, it is called general form. So it has really no functional use other than kind of makes the equation look nice and neat and tidy. Now, big one, and this concept goes all the way through calculus, and it's what a derivative is. Every line that I might graph on the coordinate plane, and so this is just an arbitrary line, has a pitch, a slant. It could pitch like this, it could go this way, it could be perfectly horizontal, it could be vertical. And what we want to come up with is one number. And just by knowing this number, I'll know how the line is oriented, which way it's going to slant, and how steep that slant is. I'll know if it's vertical, I'll know if it's a horizontal line. And so how we're going to come up with this number is just to think of this way, building a ratio. And so that if I had any 2 points on the line, and this x sub 1, y sub 1, this x sub 2, y sub 2. So if I just think about it, line here parallel to the x-axis, line here parallel to the y-axis, and which is ultimately, this is kind of how we built the distance formula, use Pythagorean theorem, but I'm not interested so much in thinking about distance, but just what is the horizontal change? And so I'm going to represent that. It looks like a triangle. Does anybody know what that, it's a Greek letter, capital.
Oh,
Which Greek letter?
I don't remember.
Begins with a D.
Delta.
Delta. All right. So in mathematics, capital Greek letter delta is used for change. And so if I'm thinking about horizontal change, I'm going to go change of x. Now, I'm going to represent this. This right here would be x of 1 on the real number line. This right here would be x of 2. I'm going to write this x of 2 minus x of 1. Now, it won't matter in terms of finding the change of x in this way, that when I find its corresponding vertical change, so we'll call that change of y, I do the calculations, and it is subtraction, but I do it in the same order that I did here. So I'll represent that with y sub 2 minus y sub 1. And then we're going to say, and we're going to use the letter M to represent this number. We're going to have change of y over change of x, which again, calculating it would simply be difference of the y coordinates of those 2 points divided by difference of the x coordinates in the same order that you did the y coordinates. And we're going to call this number slope, so that it'll give us an idea of exactly how that line is oriented just by knowing the number. So we'll put this in our list here. Or slope formula. So as far as calculating the slope, not hard at all. You need 2 points. So just if I had an example, -2, 3, and 4, -8, and these were 2 points on a line. So when I found this calculated slope, it doesn't matter what order you take the difference of the y coordinates. So say I go 3 minus a -8. Just make sure I go in the same order with the x coordinates, -2 minus 4. So up top, I'm going to end up with 11. And in the bottom, I'm going to have -6. And if I look at that, just, without looking at the graph, and I just look at, and I'll write it -11.6. I'm going to know the fact that the slope is negative. Try to squeeze this in here. That the line pitches that way. That is, its ends go up into quadrant 2 and the other end goes down into quadrant 4. Has to. How do we read? Just normally we pick up a book and we start reading. What order? Left to right. So when I look at this graph, I'm going to look at it and scan it just like I would reading a sentence in a book. Left to right, this line is what? Falling. And so lines that do that definitely have a negative slope. Conversely, lines which go this way have a positive slope. All right. So 2 other possibilities for lines, slopes, quick drawings, but could be horizontal, could be vertical. Now, in this case, if you have a horizontal line, it will have a slope of 0. So if you have a vertical line, this is the one line, can't spell. It does not have a slope. It's undefined. All right. Now, mathematically, the reason a horizontal line is going to have a slope of 0, any 2 points you pick off that line, the y coordinates are going to be exactly the same. They're constant. And so when you go calculate the slope up in the numerator, you're going to be taking a number from itself. You're going to get 0. 0 over any number except 0 is 0. And conversely, for a vertical line, pick any 2 points off that line, the x coordinates are the same. So when you go calculate the slope, you're going to be taking a number from itself in the denominator. You're going to get 0 in the denominator, and that's undefined. Kind of historically, a lot of students will remember 1, 0, and 1 is undefined. And 50-50 shot. A non-mathematical way to remember which one's 0 and which one's undefined comes from the world of skiing. If you're skiing or riding on a board and you're on a horizontal line, you have no pitch, so you're moving 0 miles an hour. If you go try to ski on a vertical line, well, you're about to become undefined. So all right. Any questions thus far?
No.
Okay. Pretty much review so far?
Yeah.
All right, good deal. All right, so picking back up with horizontal vertical lines, if I have an equation and it is y equals b, so it's just y equals a constant, that is what the equation of a horizontal line is going to look like. So And then conversely, if you have x equals a, some arbitrary constant, that's going to be the equation of a vertical line. And it's a little deceptive. If I have, you just said I had y equals 3, and you're like, well, where's the x? I could always rewrite it, put it in general form by making the coefficient 0. 0x plus y equals 3. So no matter what value I put in for x, its corresponding value, that order pair, is going to be 3. And that, again, is going to create that horizontal line. So it's the world's easiest graph. And if I said sketch a graph of y equals 3, it's literally count up 3 and put a horizontal line. So, but you want to be always at the point because we're going to have a lot of problems where we're finding equations. And if you get a situation where you're given, okay, you've got y equals 4, you need to know that's a horizontal line and that its slope is 0. All right. Next one, I'm not going to try to build per se. I'm just going to throw it out here. It looks like this. Y minus y sub 1 equals m times x minus x sub 1. And this is referred to as the point slope form. Its use in life is to determine an equation of line. That is the tool you're going to go with. So in all instances, with the exception of if you're dealing with horizontal and vertical lines, which we'll treat separately. Otherwise, if you're not dealing with those two cases, then this is, if you're trying to determine an equation of line, this is the tool you get out of the toolbox. You need two things to determine it. You need a point and you need a slope. All right, so I am running out of room here. So I'm going to turn the page. Work a problem with this. So the way it would work, if you knew you had a line and it had a slope of 2/3 and contained the point -1, 4, and said determine an equation of a line with this slope passing through that point, you put the y coordinate there, you put the slope in for m, and then x minus whatever that x coordinate was, which in this case is -1. And right at that moment, you have an equation of the line. So notice I said an equation of line. From there, you can manipulate the form. And so the homework problems here are going to say determine equation of line and then either write it in general form, which would look like this. You want to break up grouping symbols and write that as 2/3 times x plus 1, distribute to 2/3. So it'll be 2/3 x plus 2/3. You want x and y on one side. So I'm going to bring this term over. So it'll be a -2/3 x plus y. And then I'm going to add 4. I'm going to take the constant over here. So we can end up with that general form. So you're going to have 2/3 plus 4. That's 2/3 plus what? 12/3. So 14/3. And that would be general form. If you want to make it look nice and neat, I could rewrite it, make it look like this. So 2x and then -3y equals -14. So how did I get to that last equation?
Y by 3.
Careful, not 3.
-3.
-3. So that was just to make it this term positive. And that would be general form. Now there's one other form that, and it's actually really the go-to that you're going to want to write a linear equation of two variables. So I'm going to back up for a second so I can put it in our list right here. And it'll be our last one. All right. What's that one called? Do you remember?
Point slope.
No, this one's point slope here. So this,
Sorry.
you're fine. But the new one I wrote.
Yeah,
Yeah.
y-intercept, right?
Yep, that's it. So it's referred to as the slope intercept form. And the deal is, if you have a y-intercept that is any point on the y-axis, I could represent it. The x-coordinate has to be 0. So 0 and then some y-coordinate here. If I plug that in here for just any slope m, so here would be b and here would be 0, that's how I end up with this form. And at the end of the day, what is, if you put a linear equation, 2 variables in slope intercept form, it's break up grouping symbols, simplify and isolate y. And this is what pops out. But you immediately, once you put it in this form, you're going to know its slope and you're going to know where the line crosses the y-axis. So, oops. If I took this one, I'd actually just probably more apt to take it right there, because all I got to do is bring that over. This would be, so this would be general form, and this would be slope intercept in this case. Would be 14/3. All right. Two more things about lines, not necessarily formulas, but let's write it this way. Lines which are parallel have the same slope. So I think that's fairly intuitive. Now, but to be technical about it, I'm going to write one more thing to this, and have different y-intercepts. And that's just to ensure that we're talking about two different lines and not two lines coinciding. That is just basically being the same line. And 2. If two lines L sub 1, L sub 2, and I'm going to write here with slopes M sub 1, M sub 2, respectively. If these two lines are perpendicular, so they intersect each other at right angles, then M sub 1 times M sub 2 equals -1. The product of the slopes, if they're perpendicular, would be -1. Now we'll put a little, just kind of like we did here, just to cover all bases. I'm going to have, there is one exception, and that would be except for vertical and horizontal lines. Because in that case, you've got one has a slope of 0 and the other has no slope. It's undefined, so there's no way they're going to multiply to be -1, but they're still perpendicular. Now, another way to say this is that the only way two numbers can multiply to be -1, they would have to be reciprocals, but also different signs. One would be positive, one would be negative. So any two numbers that multiply to be -1 are opposite reciprocals. And so you're going to have problems where you're going to find an equation of a line using that point slope form, and you're going to have to determine the slope of the line you're looking for. You'll be, say, given, okay, the line you're looking for is perpendicular to a line with a slope in -4/3. So if then this is going to be the slope of the line I'm looking for, what would it be? If it was perpendicular to that line.
3/4.
Positive 3/4. It's just change the sign and flip it. So, all right. So what is it? 10:06. All right. So at this point, I've kind of flown through everything we need to know about the equations of lines that we'll need to deal with. So let's look at a few examples. All right. So I want you to find an equation of a line with, let's do it this way, line that is perpendicular to a line with undefined slope passes through -8.5. All right, give me a minute. If anyone thinks they have it, say, hey, I got it.
I know what the slope is. I don't know where it passes though. Of course.
All right. Anyone got it?
No.
Okay, fair enough.
No,
So this is you're going to have problems in homework that you're going to several that you're going to be finding equations of lines. So remember what I said. In all cases, you're going to turn to point slope form, except if you're dealing with what horizontal or what vertical lines. And we kind of treat those. So that's what the case we have here. And these manipulatively, there's nothing to do. It's literally just jot the answer down on this one. No calculation necessary, but you just got to, it's a matter of understanding the concept. So looking at the problem, it says find an equation of line that is perpendicular to a line with undefined slope. So the connection is, what kind of line has undefined slope?
vertical line.
Vertical line. So the line you're perpendicular to a what line that is vertical. So you know that you're looking for a what? Horizontal line. Does that make sense?
Mhm.
And then the equation of a horizontal line is y equals, and then it's a constant, right?
Yeah.
Okay. And remember, for a horizontal line, what is the constant point? It's always the y coordinate on a horizontal line. So if this is a point that this line passes through, every y coordinate has to be 5.
Okay.
Does that make sense?
Yeah.
All right. So then your other case, or you'll have problems, finding equation lines that will look like this. So I'm going to turn the page. Might be, for example, find an equation of line that is parallel to 3x plus 5y equals 4 and passes through I don't know, -1.5. Okay. So, okay, here we're parallel to this, 3x plus 5y equals 4 is definitely not vertical or horizontal. So, you're going to be using the point slope formula. All the problems will always give you a point that is on the line, at least one. And so you've got that. It's just now a matter of determining what is the slope of this line I'm looking for. So since I'm parallel to this line, I just need to find the slope of it. And the quickest way to do that is to solve for y. Put it in that y equals mx plus b form. So doing that, I have 5y equals -3x plus 4. Then divide every term by 5, and y equals -3/5 plus 4/5, and then x here plus 4/5. So the slope of this line is -3/5. So what is the slope of the line I'm looking for? -3/5. They're parallel. Then from there, I've got what I need. So y minus 5 equals -3/5 times x. And I'm going to get, if this is all right, I'm just going to say +1 because it's going to be minus a -1. So you're going to get that double negation. Now, the problems will say, put your answer either in general form or slope intercept form. Generally, I just always opt for slope intercept. In this case, distribute -3/5. So we have that, and then add 5 to both sides. So that would be 15/5. So negative or positive 12/5. On the previous problem, it'll also say put your answer in general or slope intercept form. You can just, if you have y equals 5 or x equals 2, that is general form. So you just input the answer that way. There'll be a couple of, there'll be another one where you'll be given 2 points on line, says determine equation of line. There, find the slope using the 2 points and then turn to point slope form. There's a couple other problems where you're using slope without knowing the equation of the line to determine other points that would be on the line. So like if I had a slope of -2/3, you could write that -2/3 or 2/-3, and then interpreting it as, again, a ratio of horizontal and vertical change. This would say every time you would be on the line and go move down 2, you would have to move to the right 3, and then you would hit another point on the line every time. So if I had the point 4, 2 and said find another point using slope, I could say, okay, I'm going to move down 2, which would decrease your y coordinate by 2. So now I have 0, and go up, or excuse me, go to the right 3. So 3 plus 4 is 7, but I would be guaranteed that point has to be on there. Kind of using the old, when you first learned slope, rise over run. So, all right. So that pretty much is it. There will be a couple other problems. I know the last problem typically always gets asked about. So just kind of fair warning on it. So I'm going to also assign, I've got a quiz up that covered 2.1 and 2.2. So take it once before Tuesday. So I'm assigning it, putting a due date of Tuesday of next week. So that'd be the 22nd. So it is assigned. I've got some videos if you want to watch Pearson videos up. So I'm going to go ahead and assign those for 2.3. Those assigned. And then the 2.3 homework itself. All right, it is now signed. All right, so